2.2, more on functions and their graphs preparations. Even functions and their symmetry. All right, the function f is an even function if f of negative x is equal to f of x for all x in the domain of f. The graph of an even function is symmetric with respect to the y-axis. Okay, so basically a basic parabola is symmetric. I know that's a lot of terminology, but let's see if we can delve into it. So basically they're saying is for every negative x value that we plug in here, for instance, -3, we get at +3, they both have the same y value. That's basically what this right here is saying. If I plug a negative x value in there, right, the y value is the same as if I plug in the positive one, or vice versa, right? So the y value is the same whether you plug in a negative or a positive, right? For instance, they don't have it listed here, but right there, that's actually at -1, and it spits out a +1y. There's also a corresponding one over here, whereas if I plug in a +1, I get a +y. Whether I plugged in the -1 or a +1 in the x value, they both spit out a 1 for the y value. Well, let's say, what if I do a 2, right? So let's say I plug in a 2 right here. So right here at -2, it spits out a +4. -2 times -2 is +4, right? Well, for this to be an even function, you know, the positive one has to be the same kind of thing, right? So the positive and negative. So if I plug in a +2, I get a 4. Okay, so this is the point. Whether I plug in a -1 or a +1, I get a +1y. Whether I plug in a -2 or a +2, I get a +4 for it to spit out, right? And whether I plug in a -3 or a +3, I get a +9, it spits out. So that's the point. It's an even function because that makes it true. Now, when they're talking about symmetry, they're talking about it symmetric with respect to the y-axis, which is this, you know, the one right here in the middle. And you can imagine, you can spin that around the y, and you can see that it's even or symmetric with respect to the y-axis. Both sides of the y-axis, they are identical. You could spin it around the y-axis, and it would be a mirror image across the y-axis. Now let's look if it's an odd function. Okay, so if it's an odd function, if you plug in a negative x, you get a negative f of x, right? And that's basically saying your y value is going to be the negative y value. That's kind of how you can interpret that, right? So what that means is, if, let's scroll down so we can see the rest of it. So let's say I plug in, and it doesn't list it here, but let's say we plug in a -1 right here. So let's say we plug in a -1. If I plug in a -1, -1 cubed is -1. But let's say I plug in a +1 over here, right? Okay, well, +1 cubed is +1, right? So when I plugged in a negative x, I got a -1. But when I plugged in a +1, I got a +1y, right? So if I plug in a negative x, I flip the y value, okay? And we could even do that at 2, right? So right here, let me scroll down a little bit so we can see. So right here, you see that we plug in a -2 for the x. Well, -2 cubed, -2 times -2 times -2 is -8. So it flips the sign, right? But if over here I plug in a +2, +2 times +2 times +2 is +8, and we flip the y value, okay? So we can see that this is in fact an odd function because whenever I plug in a negative x, I get a negative y value. And they have to work for every corresponding values throughout this entire function. So example, identify even or odd functions from the graphs. All right, let's try it. So we're just going to go through here and do even or odd. Let's do the even one first. Now, this one right here. Regardless, let's say whatever that point is, this is the negative x value, and it spits out this y value, that height. We can see there's an equal distance over here. That if we plug in whatever that positive x value, there's in fact a positive height right there, okay? So that works. And the same thing over here and here. Looks like it also works, right? So again, whatever this other x value is, right, it spits out a y value. It looks like the y value is 0, right? So whatever that value is. And sure enough, over here, the same kind of thing is going to be true, that the positive x value is going to spit out the same 0 y value. Now this one, it doesn't look like this one has any symmetry with all. So this is no symmetry. So we'll do no. Determine whether each graph is a graph of an even function, an odd function, or a function that is neither even nor odd. So I guess I could write neither. We'll just leave it as neither. And this one right here is even, And if you guess this one is odd, you are probably correct. Now, again, it's a little bit more difficult to think about these in terms of without actual numbers. You have to use your imagination a little bit. So here, because they're a 0, you can't really use those points. They're not really very helpful, but you can still kind of imagine whether it's positive or negative 0, it's still 0, so that doesn't really help. Whether, whatever that x value is there and whatever that x value is, that's going to be a negative version over there. But let's try this one over here. So let's assume that whatever that height is right there, this is the positive version of whatever that y value is, and this is the negative version of whatever that y value is, right? And sure enough, it looks like we have a mirror image. Okay, so we would say this is an odd one.